This is a project I'm currently working on. I'm calling it a Sketchy tool, and this is more of a block diagram here. So this bottom Uno represents a PCB design I'm working on, and this top Uno with an LED represents any sort of target project that this bottom one is going to interface with over I²C. And the idea is, if I have a project that I may need to change a variable for on the fly, and I'm not at a workbench, so I can't really just reprogram it. And even if I could, maybe I just want to make faster changes. For example, if I want to change the blink rate on an LED, and I just want to immediately see as I increase or decrease the blink rate, how do I like it in a certain application? Stopping and reprogramming might just be disruptive to trying to remember how it looked for whatever I'm trying to do. So if I can just have this I²C connection, maybe I can set a number on this LCD or OLED on this other board using a rotary encoder to set the number I want, and then click the button and it sends that data over I²C. Then this sketch could be configured to look for incoming data and assign it as a blink control variable. So I can just be somewhere else off the workbench, and on the fly I can change the blink rate, click the button, and it will take effect. And later, when I figure out the number I actually wanted in the original sketch, I can just go and update it when it's convenient. So that's the overview of this, and I'm still working on this PCB. So it does not use an Uno or an LCD. It's going to use an OLED and a rotary encoder, and then I'm using an Atmel ATtiny 0 Series 1604 chip. So I wanted to do this video to look at the software examples both of this Sketchy tool and of an example target project that it would control. And when I get the actual Sketchy tool hardware set up, I'll do another video just going over the actual hardware more in detail. For now, just looking at this schematic for a previous ATtiny 1604 project, I'm actually using this board on the workbench to do my testing while I wait for the real Sketchy tool hardware to come in. So I'm not using this part here, which is a GPIO expander over I²C on the original project. Instead, that I²C is going to go to the other project, which is coming to this Uno here. And then for the OLED display that I'm using, I am not connecting it to the same I²C, because if my target hardware also happens to use that same OLED at the same address, I don't want to interfere with it. So I'm going to be using other regular GPIO and using another library to bitbang I²C to go over to an OLED, and it won't interfere with the other I²C. And then I'll just have a rotary encoder and its push button connected up to other GPIO, and all of that is represented by this bottom circuit here. So I make changes, press the button, the data gets sent over I²C and controls a sketch on a target project. So looking at the sketch for this blink example with the Uno, just to keep things easy, I put these work-in-progress sketches over on GitHub. So here's the code that would go in that Uno, and really all it's doing, I set it up as an I²C slave with a certain address, and I have this byte called tweak data, which is going to be received over I²C, but for now I set it for 255, and that translates to the slowest possible LED blink rate. And I use this tweak data to later set this blink delay, so it's all initialized as the slowest blink rate to start. So I'm blinking the onboard Uno LED, and when I receive data over I²C, I run this receive event function. So what I'm doing, I'm only looking for 1 byte over I²C. I can expand this out in the future, but I just want to get it up and running. So I'm looking for a number between 0 and 255 to come in over I²C, and again it starts at 255. So then I map this incoming data over to a different range of numbers between 100 and 2000, which is going to represent the number of milliseconds on and off for the LED blink. So when we start up, we're going to be really mapping 255 over to 2 seconds worth of on time and 2 seconds worth of off time for the LED. It's going to blink slowly, and I do that here, setting the LED pin high and low and delaying for that blink time in between. And as soon as I2C data arrives, I read the byte into the tweak data and just send it to the serial monitor so I can see what's going on, and that's it. So now, back in the main loop, this LED blink delay is mapped using the latest tweak data over I2C between 0 and 255. So at any given time when I receive data, on the fly, I'm changing the blink rate from 100 milliseconds on and 100 milliseconds off to 2 seconds on and 2 seconds off. So if I need to be able to change this blink rate away from the workbench, all I need to do is plug in that Sketchy tool and send some data, and it will adjust. And now, looking at the sketch for this other setup, the schematic will be reviewed in the other video when I get this PCB made. But for now, just looking at it as some sort of processor with an OLED and a rotary encoder, if we look at that sketch in the Arduino IDE, I use the ATtiny core board file to get ATtiny 1604 support, and then these are basically the pins we would refer to within Arduino. So the dedicated hardware I2C pins are right here, and that's what I'm using to talk to that other Uno project to change the LED blink rate. Then I'm using other regular GPIO to do bit-banged I2C to control the OLED display, and then I'm using pins for the rotary encoder. So when I have that ATtiny core board installed, I choose the option that lets me have an ATtiny 1604, then I make sure that is the chip chosen, and I pretty much leave all these others as default, but I do have to choose the port of the programmer, which is a JTAG2 UPDI project using another Uno. I've done a video on that before. So I have to choose that as the programmer port, and I have to choose JTAG2 UPDI as the programmer for these kind of ATtiny chips. So referring to the other video on how to program these 0 series ATtinys will refresh how to do that part of it. But this is how I set it up in the IDE so I could program this chip. So here's the Sketchy tool sketch that I'm developing. It has these 3 other header files in here, all related to OLED, because at least I so far cannot find any library or anything that works with these OLEDs for the ATtiny 0 series chip. So I stumbled on this TER OLED, so a serial terminal for the OLED SSD1306, and this can do all kinds of different things. I just need it to do some text. Now, this is the only thing so far that I could really get to work to let me put text on the OLED using ATtiny 0 series. But I had a lot of trouble trying to figure this out, and I still have problems. I went through all kinds of things. There's links that go back and forth to different things and off to a dedicated website, different zip files and PDFs, and there's some older versions of code and they got updated. So ultimately, I just ended up figuring out what works best for what I'm doing. I ended up taking these 3 files, and even then I had to do some tweaking. And that's why I'm making this whole separate video. This would be way too hard to explain in a main PCB project video. So one of the things I had to modify, clicking on various links for that OLED code, I ended up on this PDF file. And what they're doing for I2C is bit banging it so I can keep the ATtiny dedicated hardware I2C pins for talking to that other Uno, but I wanted to keep the OLED on its own dedicated software-controlled I2C bus. So to do the bit banging, I found I had to go in and change some of these things because the ATtiny 0 series doesn't refer to ports and pins the same as classic Arduinos. So over here in the info for this mega tiny core that gives the Arduino support for these newer ATtiny chips. The classic Atmel parts refer to, for example, port whatever and pin whatever and data direction register whatever in a different way. So port something .out or .in or .dir. And so I went and found where this is located in this OLED code, and that brings us over to my little copy of all these files. So this one here, I guess this means bit banging for the OLED right here. I changed it to do the format of the newer ATtiny to reference these ports and registers. And I may have changed a few other things. I really can't remember because I had to do so much playing around. So in the end, really all I'm trying to say is this is what worked for the ATtiny 0 series to get an OLED running, but it wasn't easy for me. And this is my result. So taking these 3 files now for granted as just an OLED library, looking at the main sketch, I described what pins go where, and I include all these OLED I2C related files, and here's the regular hardware I2C wire library for talking to the other Uno, and I hard-coded that other Uno to be I2C address 42 hex, so I set that here, set up the rotary encoder pins, and then just some code here to monitor the movement of the encoder. I just look at one of the 2 rotary pins and wait for a change, and then I see if I went clockwise or counterclockwise. And just crude button debouncing. I just have a timer here. Once I press the button on the encoder to submit an action, I start a timer and I make sure I don't try reading this again for about 50 milliseconds. And I have another timer here. Every 5 seconds, I want to force sending out this tweaked data over I2C from this sketch tool every 5 seconds, overwriting whatever variable is controlling the blink rate here. So we'll look at that happening down in the main loop. So I do the things needed to set up the OLED, and then I just print some text at the top to say rotate and then click. And for now, it's not really doing much other than telling me did I go clockwise or counterclockwise. Later, it'll show me the actual data number increasing or decreasing. So it's just an instruction for now. And I do any other required initializations and go to the main loop. So I want to always read the rotary encoder pins and handle if I rotated it or clicked the button. Otherwise, every 5 seconds, I send out a data number 10 over I2C to this target Uno, and 10 is going to represent the blink rate of this LED. So I'm doing this every 5 seconds no matter what else, and that way, if I do change this blink rate somewhere else in the sketch, I just want it to do it momentarily so I can see that I can change the number, and then I just want it to default back to 10 on the next 5-second interval. So to send this data, I just call this function, and it sends that byte over I2C to the other Uno. And when it's time to read the encoder from the main loop, I'm looking to see if those encoder inputs have changed, and if so, figure out did it go clockwise or counterclockwise, and all I'm doing is showing on the OLED it either went clockwise or went counterclockwise. It doesn't change any data, it's just to get a foundation in place to test everything out. So once I have moved the encoder one direction or the other, I just update the fact that I just had rotation occur, so now the next time I check, I'll know did I change yet again. Then I read in the push button switch on the encoder, and I check if that went low, so it's pressed. I'm doing a crude debounce here, so that basically immediately when this switch goes low, I consider it a button press, and I do something. But as long as I'm still holding it low, or if it's bouncing faster than 50 milliseconds, I'll just use this to ignore further button presses just to keep it clean. So once I accept a button press, I need to see 50 milliseconds with this button being released before I consider a new button press valid. So we press the button and we send out data 255 over I²C. So 255 is sent over here. This sketch takes 255, maps it over to actually be 2000 milliseconds of on time and off time for the LED, and slows the blinking down on the fly. But again, back in the main loop, in this Sketchy tool demo, every 5 seconds, we're arbitrarily sending out a data value of 10, so it's going to overwrite the button click we just made, and at that next 5-second interval, data value 10 comes out, makes the LED blink faster again until we click this button again and send new data. So that's just so I can set this up as a demo and make sure everything is working. Ultimately though, the rotary encoder is going to let me set a number on this display, click the button, send that specific number, and it's not going to change it back to something else. It'll just keep that number until I change it again and click the button again and send new data again, and I can just tweak the parameters in this sketch. This is the test setup, and here is the JTAG UPDI programmer for the ATtiny 1604 on this board, which is just some older design. I'm just using it because it has that chip and it has I²C pins. Then I've connected the OLED to pins that will have software I²C. Here is the rotary encoder, and here is the Uno acting as a separate project which just blinks an LED so that I can control it outside of its sketch over I²C from here when I click the button on the rotary encoder. And this breadboard here just has pull-ups for the I²C. So if I take the rotary encoder and go clockwise, it'll say CW for clockwise every time I do that. And if I go counterclockwise, it'll say CCW every time. Or I can go back and forth. And we can see the Uno's LED right here. So when I press this, it's going to send out a data value 255, which is going to momentarily make this blink slowly. And then after a certain time period, this is going to just reinitialize the blink rate with a value of 10, which is a faster blink we're seeing now. And we're periodically, we can check here, every 5 seconds getting new blink data. But if I press this button, it's going to send 255 immediately and slow down the blink. So there's 255, and it just was time for it to send the other faster blink number. So if I do this again to bring 255, now it's blinking very slow, on and off, and now it's blinking fast again. So that's the ultimate goal with this. I can just eventually change the software so that as I rotate clockwise or counterclockwise, it'll change the number of a variable so I can actually choose what number to send, then click to send it, and it will change that parameter in the sketch on the target hardware. So that's the idea with this project. I've been talking a long time while recording this. I'm going to chop it down as best I can. I don't know how it's going to translate, but all the info is there, whether it's clear or not. So this tool just puts a hook over I²C into this other project, allows tweaking a variable on the fly, so we don't have to reprogram this until we decide on a final value that we can hard code later.